You ever hear a scientific claim that's so wild it sounds like something straight out of an alchemy textbook? Well, a few years back, a study made these huge headlines with a claim that could have literally rewritten physics. The researchers said they had created gold and a bunch of other new elements using nothing but sound waves. So let's dig in because this story, it takes a wild turn.
So that's the big question, right? Can sound waves really transmute elements? I mean, this is the kind of stuff alchemists dreamed about for centuries, turning a common metal like mercury into precious gold. And this one experiment, called the Deformed Spacetime Experiment, claimed they had actually done it. So what they did was, they blasted liquid mercury with these super intense sound waves. It's a process called ultrasonic cavitation, where these sound waves create and then violently collapse tiny bubbles. And when they checked the results, they reported finding gold, along with a whole slew of other elements that just weren't there before. We're talking Nobel Prize stuff here, if it was real. But was it?
And this is where things get really interesting, kind of like a scientific detective story. See, a claim this huge needs some seriously extraordinary evidence. And while the entire scientific community was scratching their heads over the data, one person, looking at the exact same information, spotted something that everybody else completely missed.
And that person is our detective, Nik Fenning. Now, Fenning himself says his Asperger's gives him this incredible ability to just focus, to see patterns and think outside the box. And as he was digging through the experiment's data, he found a pattern that didn't point to some kind of new physics, but to a massive oversight. Okay, so what was this first big clue? It wasn't about any one element they found. Nope, it was about a hidden link connecting all of them. This is where the whole case starts to crack wide open. At first glance, yeah, this just looks like a random list of elements. You got gold, titanium, tin, 13 new ones in total. The original paper basically said, hey, look at all these random elements we made. But Fenning had a hunch. Maybe they weren't so random after all. So what is it? What's the hidden thread that ties all of these seemingly unrelated elements together, from bromine all the way to gold? The answer? Well, it's the first real bombshell of this whole investigation. Get this. The starting material, mercury, was actually the very first elemental superconductor ever found. And it turns out that every single one of the 13 new elements is either a known superconductor itself or it forms compounds that are superconductors. That's a 100% hit rate. So you got to ask yourself, what are the odds of that? Well, the odds of randomly pulling 13 elements out of a hat and having every single one be tied to superconductivity, it's about 1 in 62,800. That is so unlikely, it's almost impossible. It's like picking one specific person out of a giant, sold-out football stadium completely at random. It's gotta be a clue, right? It means some kind of sorting process was going on. Something was choosing only these specific kinds of elements. Okay, so this massive statistical clue pointed Fenning in a new direction. He started hunting for a physical reason, and he found it. He found a crucial detail, a variable the original researchers just completely ignored. So to get what's happening next, we got to quickly talk about something called electrical resistivity. Basically, think of it like friction for electricity. The less friction, or the lower the resistivity, the easier it is for electricity to flow. And superconductors, they have zero. None. Zip. And folks, this right here, this is the smoking gun. See, other studies on other liquid metals had already shown that if you blast them with ultrasound, their electrical resistivity just collapses. It plummets. The original team, they never even measured it. And for a metal like mercury, which is super sensitive to electricity, this effect would be huge. It would push it right to the edge of being a superconductor. So you put these clues together, right? The crazy superconductivity link and this overlooked resistivity collapse, and Fenning came up with a whole new theory. And the best part? It doesn't need any new magical physics. It's all based on stuff we already know. He calls it the runaway galvanic boosts. So how does this runaway boost thing actually work? Well, think of it like a four-step chain reaction, a feedback loop. 1, the sound waves hit the mercury and its electrical resistance just nosedives. 2, with less resistance, the local electrical fields and electron activity go nuts. 3, as new atoms start forming, the whole environment is now rigged to favor only the ones that are great conductors. And 4, and this is the genius part, these new elements make the resistance drop even further. It's a loop that feeds itself, a self-reinforcing cycle that only selects for elements that can play the superconductivity game. It's not random, it's a selection process. So at the end of the day, you've got two completely different stories.
On one hand, you have the original theory, which had to invent brand new, unproven physics to explain what they thought was a random mess. On the other hand, you have Fenning's theory, which uses solid, known physics to explain a very, very specific result. I mean, which one sounds more likely to you?
And when you start looking at it that way, man, it changes everything. If these elements weren't a mistake, then what were they? Fenning's theory suggests they were the exact ingredients the system needed to get into that super-efficient, low-resistance state. So the experiment wasn't a failure at all. It accidentally stumbled onto something way cooler.
And this is the real kicker. The data wasn't about turning lead into gold. It was a recipe, a precise formula cooked up by the laws of physics right there in the experiment for a totally new kind of material.
And when you look at the numbers, you can see it's a super specific recipe. This isn't just a random soup of elements. You've got a ton of bromine, a good chunk of titanium, and then these exact smaller amounts of other stuff. This is literally a blueprint for a mercury alloy that someone could actually go into a lab, mix up, and test.
So where does all this leave us? Well, this whole detective story completely flips the script. It takes this controversial, maybe failed experiment and turns it into a potential starting point for a revolution in material science. And now, there's a clear roadmap for what to do next.
The path forward from here is actually pretty straightforward. Phase 1, you validate the whole idea. Go in and actually measure that resistivity collapse when you hit it with ultrasound. Prove the foundation is solid. Phase 2, you synthesize it. You literally follow the recipe, create this mercury alloy, and test it to see if it's a high-temperature superconductor. And then, there's Phase 3. This is where it goes from cool science to straight-up science fiction.
Yeah, check this out. A dynamically doped liquid superconductor. The idea is, instead of making a solid thing, you'd use perfectly tuned sound waves to constantly create these little superconducting bits right inside the liquid mercury. You'd be holding the liquid in this supercharged, high-performance state. We're talking about a completely new type of liquid metal technology. So we end up back at this incredible question. Did a scientific mistake, something that looked like it was bending the rules of reality, actually stumble backwards into a blueprint for a whole new era of technology? It's just an amazing reminder that in science, sometimes the biggest breakthroughs come from the places you least expect.